Hello everyone, welcome back to my channel. So in this video we are going to learn about electric field intensity due to circular ring. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get the notifications regularly from my channel. Right, so what is circular ring? Circular ring is line charge only. Okay, so line charge only, so that is rho L, which is coulomb per meter, is converted in the form of ring. That is a line charge here. Okay, so which is extending like this is converted into a circular ring like this. So everywhere the charge exists at the edge of this circular ring. Okay, so when this line charge is converted in the form of circular ring, then what is its electric field intensity we have to find. Right, so let me take a circular ring to explain this concept. Okay, so consider this as circular ring. So next I am drawing you the coordinate systems. Right, this is X, Y and Z. Okay, so this is the point of interest P, 0, 0, H, that is it is existing at a distance of H from origin. Okay, so I am considering a small length here, differential length. Okay, DL. I am considering the differential length DL. So same differential length will exist in the other direction also. Okay, so the distance from here to here is equal to the same. So this is the radius of the circular ring. Let the radius of the circular ring be A. So here A, small a, represents the radius of circular ring. So this total value is the radius of the ring. So this is A. So if this is A, this will be, so in this direction it is increasing from 0 to the line charge, that is from the 0 to circular ring. If it is increasing, okay, then from O to A also it is increasing A. Right, so this is H and I am drawing a line which joins the, so I am drawing the line, straight line which joins this differential length to the point of interest P. I am assuming that as the R bar, distance is R bar. Okay, so I am assuming that as R bar. Try to understand, very simple concept. So line charge is first converted into circular ring. So I have taken a circular ring, so I have drawn the coordinate axis. Okay, along Z this electric field line charge is existing. I am taking it as along the Z axis. So point of interest is 0, 0, H, that is it is at a distance of H. Okay, so let A be the radius of the circular ring. So this will become radius. So I am considering a small differential length DL. Okay, so next same differential length will exist in the opposite direction also. Right, and then I am taking the distance vector R bar, okay, along the differential length considered and the point of interest. Understood here? So if you have any doubts, you can comment in the comment section. I'll explain you again. Then what is the electric field intensity? E bar is equal to, this is same as line charge density as I have told you, rho L dl into AR cap divided by 4 pi epsilon naught R square. Okay, so integral rho L dl into r bar divided by 4 pi epsilon naught into r cube. So AR bar, because AR bar is equal to R bar by R. So R square into R becomes R cube here. Then what is R bar? From triangle law of vectors. So again, if this is P, let this point be M. So from the triangle PMO. So from the triangle PMO, I will redraw this triangle. This is the triangle PMO. So this is P and this is M and this is your origin O. So this is H, this is your R bar, and in this direction A will increase. So this is A. Okay, right. So A represents here radius only. Okay, so R bar is equal to, so R bar is equal to MO plus OP. MO in the direction of O to M, A increases, but when you are taking from M to O, A decreases. So I am taking it as minus A. So in this direction it is increasing, in the reverse direction it is decreasing, so we will take it as minus A. If you take the magnitude, you have to take it as minus A into aero cap, because it is representing the radius, plus H into AZ cap. It is along the Z direction. H is along Z direction. So this is your R bar. So what is R then? Root of A square plus H square. Then what will be R cube? A square plus H square whole to the power of 3 by 2. Right? I am substituting that here. E bar is equal to integral L into rho L. So here we have to consider one more thing here. So I'm taking very small value of differential length. We're taking very small value of differential length. Okay, and this is your angle phi. So when I'm taking a small value here, differential length value is very small, and this is your radius A. Okay, I'll draw one more line here. Right, I'll show you in one more circle. So this is what we have taken. So this is A we have taken, and this is total phi. This is phi. So for a small value, this becomes d phi. Small angle becomes d phi, and this total length becomes dl. Okay, so this small angle I am talking about inside the angle. So this is d phi. Okay, so this is d phi. Then what will happen? D phi can be written, when length is very small, you can write it as A into dA. Sorry. So this is your angle d phi. So how can you write dl? dl can be written as A into d phi. Okay, so actually d phi, when d phi is equal to, if you take cos of angle also, sine angle also, sine of d phi is equal to, opposite side is dl by A. dl by A. So dl, when phi is very small, sine phi is equal to phi. Okay, so sine phi is equal to phi. So d phi is equal to dl by A we can take. So dl is equal to A into d phi you can take. Okay, for small angle sine phi is equal to phi. So due to this reason, you can write dl as A into d phi. Okay, so rho L into, so dl is there here, so we can write it as A into d phi into R bar. What is the R bar? R bar is minus A into A rho cap plus H into AZ, divided by 4 pi epsilon naught into R cube. R cube is A square plus H square whole to the power of 3 by 2. Okay, so if you observe here, whatever the electric field intensity in the direction of rho, I'm talking in the direction of rho, whatever the electric field intensity here, there will be the same electric field intensity. Okay, so there will be same electric field intensity but of opposite direction, so that means one along positive y-axis, the positive y plane, positive xy plane, then the second will be along negative xy plane, so negative in direction. So both will be cancelled off. So along this rho direction, that is a rho cap, so electric field intensity is going to be cancelled out. Electric field intensity E bar cancels out with each other. So in this direction, in the direction of rho, E bar is equal to 0. Everywhere it will be cancelled off. If you take in this direction, so this will be dl, and in the opposite direction you will have the dl, which is equal and opposite in magnitude. So everywhere in the circular ring, so along a rho, E bar will be equal to 0. So electric field intensity due to this term will be cancels off, and hence electric field intensity will be existing for only this term. Okay, so that is the consideration here. So integral L rho L into A d phi into H A Z cap divided by 4 pi epsilon naught into A square plus H square whole to the power of 3 by 2. So integration is with respect to A d phi only. Okay, all the remaining terms are constants, you can take outside. Okay, so and the phi varies from 0 to 2 pi, so we know that phi varies from 0 to 2 pi. Okay, let me write again. Okay, so this integration will be now integral, I'll write the constants first. So rho L is a constant, you can write outside. A is a constant, H is a constant, divided by AZ cap is also, you can write outside. 4 pi epsilon naught A square plus H square whole to the power of 3 by 2, everything is constants. So integration is from phi is equal to 0 to 2 pi d phi. Okay, so understood this. So is equal to rho L into A into H divided by 4 pi epsilon naught into A square plus H square. So integral of d phi is phi, and if you substitute the limits you'll get 2 pi. So into 2 pi AZ cap. So E bar is equal to, so 2 pi here, this becomes 2. So rho L into AH divided by 2 epsilon naught into A square plus, so this is 3 by 2. A square plus H square 3 by 2 AZ cap. Okay, so this is the formula for electric field intensity due to circular ring. Okay, so this is the formula, this is the final formula for electric field intensity due to circular ring. Here H represents the distance of the line, distance of this line charge from the origin on Z axis, and A represents the area, radius of the circular ring. Okay.